Hello everybody, Gavin McCormack here. Welcome to this course, The History of the Earth, a Journey Through Time. We have travelled all the way from Australia to Iceland, and we're about to take you on a journey like you've never seen before. We're going to start at the very beginning of Earth's creation. Yes, the Big Bang. We're going to go through to glaciations, we're going to go through mass extinctions, and we're going to help you understand everything with our favorite geologist, Marcos, who's traveled all the way from Argentina to join us on this journey. We're going to be climbing volcanoes, studying lava, and looking at how the Earth has changed so many times, but still survived. But what we're going to do, even more important than that, is empower you, to show you that you are part of this big 13 billion year story about nature, and that you are nature. Because when we understand that we are part of this whole mechanism and we have the power to change it, then hopefully we can make a better future. During this course, we're going to achieve SDG number 15, life on land, because that is where we live. We're going to learn from the Icelandic culture, the Icelandic people, and geologists from all over the planet to make the world sustainable and a better future for every single organism that lives on this blue ball that we call planet Earth. Welcome to this course, The History of Earth Through Time, with me, Gavin McCormack.
Close your eyes for a moment. Imagine nothing. No stars, no planets, no air, no time. Just an endless, silent darkness. And then, in a single instant, from something smaller than a grain of sand, the universe exploded into existence. This wasn't just any explosion. This was the birth of everything we know: space, time, matter, and energy, all bursting out in a flash of unimaginable heat and light. Scientists call this moment the Big Bang, and it happened 13.8 billion years ago. At first, the universe was hotter than 1 million suns combined. There were no planets, no people, not even atoms. Just tiny, swirling bits of energy racing outwards, stretching space like a giant balloon inflating at the speed of light. But as the universe cooled, the very first building blocks of everything began to take shape. Hydrogen and helium, the same gases that make up the stars, came together. And after millions of years, gravity pulled these tiny particles into glowing balls of fire. That's right. The very first stars. Stars which lit up the darkness for the very first time. And so, from a single cosmic spark, the great journey of the universe began. And you? Well, you're made of the dust of those very first stars. You are part of this story.
Hello everybody, Gavin McCormack here. We have travelled all the way from Australia to Iceland for this course, A History of the Earth, a Journey Through Time. And why have we come to Iceland? It is filled with life, and I'm not talking about animal life, although there is a lot. There is volcanoes here, there is lava, fissures, geysers. Literally, this place is completely alive. We're going right back to the very beginning. Yes, we're going back to the Big Bang. And we're here with Marcos. How are you?
Hey Gavin, nice to meet you.
Yeah, you too. Now Marcos is a geologist. Marcos, tell us, what does a geologist do?
Well, geologists study rock. They study the planet, not only our planet, but also planets that are in our solar system and all around. And we track back through time and we try to piece together the history of these places.
Cool. Now, so I'm going to be spending it with you for a really important reason. You see, history is about going back in time and looking at the past. We're going back to the very beginning. In fact, we're going back to 13.8 billion years ago to the beginning of the universe, something called the Big Bang. Can you tell us what happened 13.8 billion years ago that shaped the entire universe and made it completely different?
So this is, of course, very hard for us to grasp and comprehend. It is so unimaginable, this big explosion that happened so far long ago. But physicists believe that there was a very, very tiny place where a lot of mass was concentrated, and 13.8 billion years ago this exploded into our known universe. So it was a very, very tiny place that concentrated a huge amount of both energy and matter.
So what we're talking about here, and it's really hard for our children to grasp at home, but something smaller than a grain of sand, everything in the universe was packed into there. There was a huge explosion. What came out of that explosion at the very beginning?
So from that very beginning, pretty much everything, all matter that we know of, was generated from there. So it had to, of course, expand at a super high speed, almost instantly. So in the very first seconds already, that very small speck of space started to grow and grow at a high speed. And even today, the universe, we know it's still growing.
And there were four really fundamental elements that were born on that day. What were they?
So closely after this Big Bang happened, matter started to shape in the atoms that we know of today. That wasn't possible in the very first seconds, but after a short period of time, atoms started to form. And those atoms were the very first atoms were the less protons and less electrons, like hydrogen and helium and all up to lithium. But those are the only elements that were present in the beginning of time.
Now, 13.8 billion years has passed and there are so many more elements now. There's been some heating and some cooling and some coalescing and some collisions, and we have so many different elements now. Now, for our children at home, we have this origin, this 13.8 billion years ago, hydrogen is formed in the Big Bang. Now, just so that we're all aware, I, you, everybody who lives on the planet is about 10% hydrogen. In fact, hydrogen and oxygen, H2O, is water. We are 60% water. In fact, your brain is 75% water. So we could say that when the Big Bang occurred and those elements were formed, that the building blocks for our lives as humans and insects and plants were also formed.
Definitely. That came a little bit after, because in the beginning, as we said, it was only those elements and those elements alone. But what happened later is that some particular places in that universe that was formed were a little bit more dense. And what happened is that those elements started clamping together, forming the very first stars. And what happens in stars is that a huge amount of energy is released, and those elements generate new elements. They fuse together and they generate a huge amount of energy that can create new elements out of them. So then all of the rest of the elements that we know of, like the jacket that you're wearing, it's not only hydrogen and helium, it's a lot of different things. They formed into the bellies of the stars. So this fusion, this cooking of elements happen in stars.
Amazing. Now, if we look at our galaxy alone, the Milky Way, we have around 200 billion stars. That's 200 billion suns. Each one of those suns has around about 5 to 15 planets orbiting it. We are standing on one of those planets, Earth. How did it occur? How do we get from the Big Bang with hydrogen and helium and lithium and beryllium to suddenly having a planet that we can live on? How does that happen?
So again, that took a long time, But from that beginning of clumping together of stars in the beginning, some of those stars actually exploded and generated new dust that spread it around space and new elements as well. And eventually our galaxy, the Milky Way, that was a huge cloud of dust. And that dust started clumping together. Mostly that dust formed our sun. The sun that is 99% of the mass of our solar system is actually the sun. And all the rest of this dust of elements were the rest of our planets, one of them being Earth. Of course, the planets that are closest to our suns are these rocky planets, and the gas, this massive planets are these gassy planets were a little bit further away, and we know that now as our solar system. But it was those elements clumping together, forming what we know of today as our planet.
So what we're talking about here is a huge amount of gas, a huge amount of materials, elements thrown out into the universe, into the cosmos. Then they're coming together to form suns and stars and planets and moons. And one of them just happened to be Earth. We're in the perfect spot.
Imagine standing on a planet where the ground is lava, the air is poison, and fire rains from the sky. No trees, no oceans, just a world of boiling rock and chaos. This was Earth 4.6 billion years ago. They call it the Hadean Era, named after Hades, the ancient god of the underworld, and for good reason. You see, this was no place for life. Volcanoes exploded without warning, hurling rivers of molten rock into the air. Asteroids crashed into the surface like cosmic cannonballs, shaking the planet to its core. And above all, a thick cloud of toxic gas swirled, trapping the heat and turning Earth into a fiery, glowing furnace. But even in all the destruction, something incredible was happening. Beneath the chaos, Earth was taking shape. The land cooled, forming the first rocky crust. Deep inside, a scorching hot core of iron and nickel was born, creating the magnetic shield that still protects Earth today. And then, the greatest transformation of all, the arrival of water. Some came from deep within the planet, bubbling up in steam. Some was carried by icy comets crashing down from space. Drop by drop, rain began to fall, cooling the hot planet, filling the craters and forming the very first oceans. The world was still wild and dangerous, but the stage was set. The first ingredients for life were now in place. And so, from fire and fury, the Earth was now ready for its long journey towards life.
Now we've learned that 13 billion years ago the universe was formed from the Big Bang, but we were a long way away from having an environment like the one we can see around us today, with rivers, rocks, mountains and fjords. Now if we fast forward and we go to around about 4.6 billion years ago, we find something called rock. Now this is a piece of basalt. Now as all of the elements from the Big Bang started to accumulate and coalesce, they developed planets and suns and moons, and our planet, Earth, was a big fiery ball. But as that lava started to dry, it changed form and it created something magical. This is basalt. And the first basalt was formed around about 4.6 billion years ago. Let's go find a man who knows exactly how the whole process happened. Let's go. Now in the Hadean Era, 4.6 billion years ago, the rock on this Earth started to form. The basalt around me started to be created, and we had an Earth's crust. But still, there was no life. There was a ball of molten rock covered in this hard surface, which is the rock you can see here. Now, something remarkable happened between 4.6 billion years and 2.8 billion years, and that was the arrival of water. Water, just like the stuff you can see here. Now, with water, as you probably know, comes something very special: life. That life was the life that would eventually become you and I and every creature living on the planet. Let's have a taste. Wow, delicious. Now, as the Earth started to change and all of the magma and lava started to dry, the formation of the planet would change forever. We would now have rock, we'd have mountains, we'd have landforms, we'd have water, and that would eventually lead us to having life, complex life, just like our bodies. And we found Marcos. Marcos, how are you, sir? We are again.
It is good to see you again.
Now, Marcos is a geologist, and we've climbed to the top of this huge waterfall here to learn about the Hadean Era. What an amazing era.
It was. Since the beginning of our planet 4.5 billion years, all until 4 billion years, it is called the Hadean Era. I'm going to explain why in just a minute. Our planet was nothing like it is today. It was very, very hot, warm, volcanoes spewing everywhere, even asteroid impacts that were colliding with our planet constantly. The atmosphere, the sky wasn't blue, it was a different composition, so actually the sky was red. Red, full of CO2 and methane and all these things that we wouldn't be able to breathe right now. So it was very inhospitable, and this is why we call it Hadean. Hadean for the Greek word underworld.
Wow, so this dark red bubbling underworld, a fiery furnace. No life could possibly live there.
Nothing could have lived there.
Now, I understand that the lava, the magma, this fire started to cool and change from some kind of liquid form into rocks like we see here. How did that happen?
Exactly. So even though it was a very inhospitable moment in time, it was very important, because from there, Earth started to evolve. The first process was a process called differentiation. So the Earth crust started to form as we know it today, and a lot of the heavier elements sink down into the mantle, into the core of our planet.
Wow, and that's why the center of the Earth is made of those heavy elements like iron.
Exactly, iron and nickel, and those things just sink down in that precise moment. Not only that, but it is thought that a big asteroid impact created our moon. A huge chunk of our planet got dislodged and became our moon. So very important things started to happen. Another one of those is that there was all of this bubbling that put a lot of the gases that we know now to be our atmosphere and would then become the ocean.
Wow.
Because this was the moment in time when all of this happened.
Right, so let me just get this straight for everybody. The Earth cools, the magma dries, rock is formed. But in that great exchange, that manifestation of this new planet, we have gases released, and those gases change the atmosphere into this atmosphere that potentially we have today.
Exactly. In the beginning, all of this warmth outgassed this very, very warm planet, and it put all in the atmosphere, but Earth was still very hot.
Yes.
So nothing was able to precipitate yet, because everything was even higher than boiling point.
Right.
At a certain period in time, back in that period, things cooled down enough for some of these elements to precipitate.
Okay.
So rain and rain and rain followed through centuries, even millions of years, and that formed in the deepest part of our planet, our ocean.
Wow, so these mountains were formed, these rock formations, and then the great rains came, and how unbelievable that it rained for hundreds, if not millions of years, non-stop, causing the rivers, oceans, and waterfalls just like the ones that we have here today.
Exactly. If you try to picture the volume that is in our oceans currently, today, you need to picture that that didn't happen from one day to the other. It was a long and ongoing process that lasted for a long time.
Wow, how remarkable that the Earth we have today, which is so peaceful and blue and green, started off in the Hadean as a big fiery red ball. And what was so important about the formation of these waterways?
The important thing is that by now, with this inhospitable Earth, it led us to having all the right amount of things and materials. We have the atmosphere, we have the oceans, we have the rocks, we have an Earth that is a little bit cooler. Now we are ready for something that's very important. It transformed the planet as we know it today. That is the beginning of life.
Wow, okay.
Imagine a world without land, without trees, and without even a single breath of oxygen. 4 billion years ago, Earth was a very different place. An alien world of fire and water. The sky was thick with poisonous gases, and the oceans boiled with heat. Volcanoes erupted endlessly, shaping the planet's surface. But even in this extreme world, something extraordinary was happening. Life was beginning. Deep in the oceans, near scorching underwater vents, tiny microbes, the first living things on Earth, came to life. At first they were simple, just single-celled bacteria, but they were survivors. And over millions of years, they spread through the oceans, changing the planet, bit by bit. Some of these tiny creatures began releasing a gas that would one day make all life possible. That gas was oxygen. The air wasn't ready for oxygen yet, but the process had begun, and the world was changing. The Archean Era was the start of something bigger than anyone or anything could have ever have imagined. From these tiny life forms, the long journey of life on Earth had begun.
But back in the Archean era, the atmosphere was mostly methane and ammonia, which is extremely poisonous for us to breathe in. So how did it change for life to form? Well, they say that it all happened with plants being able to provide oxygen for themselves using the energy from the sun, something we call photosynthesis. Let's head up to the top of the mountains and find somebody who can tell us all about it. Let's go. So the atmosphere had changed and the composition of Earth looked completely different. We were now in the Archean era, and we've walked up the mountains here to find a specialist who's going to explain to us exactly how life began. Marcos, how are you, sir?
Hey, Gavin. Good to see you again.
Yes, you too. Now, coming into the Archean era, we've got this Earth. It's covered in lava. It dries. It's covered in basalt, a little bit like the rock I'm holding here and other rocks too. What happens next? It starts to rain. What happens to the look and feel of the Earth?
Exactly. So next, Earth is not as hospitable as it is now, but it's definitely not as at the Hadean. It starts to cool down, we're starting to form the oceans, and we still are lacking a lot of the features that we can see nowadays. So of course nowadays we are here surrounded by mountains, by fjords. There were not a lot of land back then. If you would have flown over Earth back in the beginning of the Archean, it would have been mostly an ocean and just a few spewing volcanoes here and there. Plate tectonics and the formation of the continents as we know today was not developed yet.
Wow, and we have this lifeless planet covered in this liquid, this ocean, filled with rich nutrients and minerals, and then suddenly life springs out of nowhere. What's the theory there? How does it appear?
Well, it's fascinating, and it's one of those puzzling things still yet. This is one of the main questions that we have. Like the Big Bang is a big question, here the beginning of life exactly is a big question mark. We know some of the context, we know what should happen, but we don't know exactly for sure. So there's a couple of theories actually of how the very beginning of life started. There are some theories, for example, one that is the panspermia theory, that is that an asteroid brought already this seed for life from outer space. And there's another one that are just coined by many very famous scientists like Charles Darwin, that life started here on Earth And in the water, in this vast and expansive oceans, we had the possibility, this soup of elements and chemical reactions where life began.
Wow, and why are we sitting by this puddle?
So we're sitting by this puddle because we know that if it happened on Earth, and it happened definitely in the water, where these chemical reactions, these different nutrients, and this heat source was present.
So this puddle here would be the perfect place. It's got heat coming from the sun, there's light also, and the earth is quite warm. And we know that all three of those things make it perfect for life. Now, life then starts to change because we have these simple organisms living in the water. What are they feeding on?
Yeah, so in the beginning, these are very, very simple organisms to our own standards of today. So these are microscopic organisms, we call them prokaryotes, and the similar thing that we can compare them today are modern day bacteria. They are unicellular, they don't have any nucleus and any organelles that have special functions, they just do one thing and it's surviving. And what is life to begin with, and what's the difference between life and non-life? A lot of things move. So life has a few things in common. One thing is that it has a metabolism. It kind of fuels itself somehow, and we'll talk about this in a minute. Another feature that it has is that it can reproduce. It can duplicate itself. Different ways of reproducing along the way, but it definitely does that. And then it has some kind of self-replicating code to make it last in the future and evolve through time. So those are the things that life needs. So you asked me about what it feeded off, and in the very beginning it feeded out of these chemicals and the heat, and that was enough for this early life to go by.
But we have something in the Archean era called the boring billions. Now, we know it's actually not so boring because all of this is so interesting. What it means is there was a long space of time where the life that lived in a puddle, maybe just like this, didn't really do much. It was just getting by and learning how to live. But then something remarkable happened. What happened at the end of the Archean era that takes us into the next era?
Yeah, exactly. So this moment in time, and really prokaryotes, this early life, take about 2 billion years of Earth's life. It's about 55% of all the time that life was on Earth was this very primitive life. And this is why we sometimes call it a boring billion, because there's not much happening in terms of evolution. These very primitive organisms stay and live for a long period of time without doing much, seemingly. So then what happens is that some of these creatures that were sustaining themselves only by these chemical reactions, they rise up to the surface and they learn a new treat, a new superpower.
Wow. So tell me more about this special skill, this superpower that these organisms evolved to have.
Yeah, so these prokaryotes, they still were very primitive organisms. They still were single-celled, but they learned this new treat of something that we call now photosynthesis.
Now what is, I've heard this name, photosynthesis. What happens?
So photosynthetic organisms, what they do is they harness the energy of the sun. So we have a lot of energy that's coming from the sun all the time, and they learn how to convert that energy, this incoming solar radiation, into molecules that they are stored in their organisms, and they produce energy out of that with only water. And they don't do this alone in isolation. They consume something and give something back in return. So what they were doing is they were exchanging CO2 that was very abundant in the atmosphere, and they were giving oxygen back to the atmosphere.
Wow, and this would have changed the atmosphere and setting it up for success for organisms like us to breathe later on.
Yes, exactly. What was fascinating about this moment in time is right up until life began, all of the changes in our planet were done by this inorganic phenomenon. So we talked about gravity, we talked about dust, we talked about the Big Bang. All of this was without life, and now it was life that was starting to change our planet.
And this change would set us up for a great future ahead of us.
Exactly.
For billions of years, the planet had been a hostile, barren place. But deep in the oceans, microscopic life was stirring. Tiny bacteria floating in ancient waters began to release a gas that would change the world forever. Oxygen. At first, it was poison, wiping out many early life forms. But over time, it reshaped the atmosphere, setting the stage for something extraordinary. For the first time, life grew more complex. Simple cells joined forces, forming the first multicellular creatures, the ancestors of everything we know today. Meanwhile, massive ice sheets came and went, sculpting the planet and testing life's resilience. The Earth was no longer just a world of fire and rock. It was transforming. It was preparing. And soon, life would be ready to rise.
Life had begun in a small pool in the oceans, in waterways all around the planet. But the life that had happened was very simple, and it was relying on the nutrient-rich soup that it was living in. Then we move along to 2.5 billion years, and things are about to change. The life that lives in this water is about to evolve. It's about to change into something very special, and it's about to learn something that would stand the test of time and set up the future for all living life. That's right, life in water was about to learn how to photosynthesize, to harness light and heat and turn it into its own energy source. And we are very lucky today to be in Iceland because we're about to meet Marcos, our local Icelandic geologist, who's going to tell us exactly how the whole thing played out. Hello, Marcos! Good morning, Marcos, how are you?
Good morning, Gavin.
Wow, nice day.
Excellent day.
So beautiful, I just saw a seal here.
It is. It's very, very beautiful here.
Now we're so lucky to have Marcos here because the Proterozoic Era is such a busy time in the evolution of Earth, Marcos. What really happens at this time?
Yes, it is. It's a very exciting time, the Proterozoic. A lot of the continents were starting to form. Life was starting to evolve, and not only that, but life was making our planet evolve. The atmosphere, the oceans, they were changed by the presence of life. And a lot of this is due to photosynthesis.
Right.
So I was today studying out there phytoplankton, and it has a lot to do with photosynthesis.
Right, okay, so shall we go and find out more?
Let's go on into the water.
Okay, let's go. Wow, Marcos, this is amazing. We're on the water here in Iceland, and we're here for a particular reason because the world changes. 2.5 billion years ago, we're in the Proterozoic Era. Now, we know that life is starting to get complex, but let's go back to the geology. The world as we know it changed. It was covered in oceans, and suddenly continents appeared. How did that happen?
Yes, exactly. The reason why continents forms is actually due to plate tectonics. And we're going to talk about plate tectonics in a little bit. But plate tectonics started somewhere nearby 4 billion years ago, and it changed the planet as we know of. The main thing that it did is that it created a lot of what we know now as the continents. These floating masses of crust that are just always there. They're moving around the planet, of course. They are not in a specific place and stagnant. They are moving around, but they were created through time.
Now, it's a very big question because you've got this solidified Earth, there's a crust, it rains for 2 million years, there's 18 quintillion liters of water pour down, rain down on the Earth, and suddenly some rock decides to float and some rock stays at the bottom of the ocean. You've got oceanic crust and continental crust. What determines which one rises and which one doesn't?
Earth has a lot of different elements, and these elements nucleate and they form together different minerals.
Right.
So not all minerals are the same, and not all minerals weigh the same. So the basic characteristics that made some minerals to stay afloat and some to sink down is the density. So the density of the minerals is very important, and the continents are mostly made out of granite. Granite is a rock that has a lot of lighter elements. Lighter than they keep themselves buoyant.
So we have this granite floating to the surface, becoming continental crust, not just granite, but many different components, and specifically heavier rocks sinking to the bottom.
Exactly.
Now in the waterway and in the oceans, we have this simple life. We have these organisms that are starting to feed and live off the nutrients, the great soup, as you called it, in the water. But they've evolved. They started to learn how to harness the sun's power. We call this photosynthesis. What is photosynthesis?
So photosynthesis is actually the capability of harnessing the energy of the sun and convert it into chemical energy that is stored inside these organisms.
Right.
So this is kind of like a superpower. You only need the energy of the sun. You don't need to eat anything. You don't need to feed yourself onto anything else. You just need some nutrients, some water, and the sun.
Wow, and so now life can sustain itself. It doesn't really need anything apart from what's available all around it. And I guess this is the time when not evolution began, but when the significant change in life started to happen. What started to happen here? Because now our organisms can harness their own power. Something happens in the way that they replicate. What happens?
Yes, so a little bit of the consequence of this photosynthesis is that in this exchange, they take something in that it's carbon dioxide, and it was very abundant in this primitive atmosphere, but they go and they emit some oxygen in return. So this photosynthetic formula and this photosynthetic process, it feeds in oxygen to the atmosphere.
Right.
So this starts to change the composition, not only of the atmosphere, but also the oceans themselves.
Right, okay. And then life starts to evolve. What happens to these organisms once they start to duplicate?
Exactly. So in the beginning, there were only what we know now as prokaryotes. And these prokaryotes are similar to modern day bacteria. They were really simple. They lack a nucleus, they lack organelles, that they are specialized cells to create different things. And at some point, this amount of oxygen allowed for more complex life forms to rise. And these are the eukaryotes. The eukaryotes now have a new organization, internal structure, and you can compare the prokaryotes with the eukaryotes. They are very different ways of organizing themselves, and the eukaryotes now can have specific cells that are dedicated to tasks like reproduction, like respiration, like digestion, so they can get more complex with time.
Wow, and little did they know that all the way back 2.5 billion years ago, when this evolution happened, this would be the building blocks for life as we know it today for human beings, because the atmosphere has changed. It was methane and it was poisonous, it was ammonia. Now it starts to become oxygen and nitrogen, and we have this beautiful atmosphere we're here, living here today. But I think the miracle of how that happened is quite complicated, and I think right now we're going to head off and have a look at some simple life that's going to help us explain just that. Okay?
Sounds good.
Let's go. So we've arrived at the perfect spot to find some of these organisms. What are we about to see?
Yeah, so the oceans are actually full of these tiny little organisms that are called phytoplankton.
Right.
And I was about to deploy a small net that would allow us to observe this phytoplankton a little bit better. Of course, they're really, really tiny. We need to take them to the microscopes, but this is what we were about to do.
Wow, okay, and this is, in the same family as this very simple life 2.5 billion years ago.
Yeah, so the cyanobacteria are these photosynthetic organisms as well, and they are inside the family of what we denominate today as phytoplankton. They are only one type, and they are one type that lives in specific places, but it is actually one of them.
Okay, let's go then.
So we're now dunking this small little net, and this has such a fine mesh size that it allows us to filter the size of the particles. This is a very, very small organism again, so we need them to be collected in this small little jar. So after we are sure that it's sinking under, we are letting it go behind us, and slowly but surely it will trail and follow us along the way.
Wow, looks brilliant. It's almost like fishy.
It's almost like fishing.
Okay, so now that the net's in the water and we're collecting this phytoplankton as we drive along this beautiful lagoon in this fjord, photosynthesizers play such an important role in so many ways. Not only keeping us alive by letting us breathe, but also regulating the climate. The world is getting hotter, ice caps are melting, the seas are getting hotter. What role do these guys play?
So other than the exchange that they do in terms of gases in the atmosphere, they're also at the very base of the food chain. So that means that anything in the oceans is feeding on phytoplankton at some level, maybe directly, maybe indirectly, but being at the base of the food chain, they feed the zooplankton and things like krill, for example. That krill feeds seals and fishes and whales. Anything relies and everything relies on these tiny little creatures.
Oh my goodness, what an important role to play. Now my last question before we move on to our next era is this: how do you know that this happened all the way back 3.5 billion years ago? There was this great oxygenation event which changed the atmosphere. Methane is gone, oxygen is starting to appear. How do you know? How do you know? Do you have a time capsule? Do you go back in time? What do you do?
So that's the beauty of geology, and this is why I like it and I love it so much. The geology and the rocks are the only ones that stand the test of time. They are the only ones that can tell us this old history. So again, the history is written in the stones. So the geological record keeps some of the stones that were only possible before the oxygen was available. So in this early Earth, again, we had several orders of magnitude less oxygen than today. And that allowed for some rocks, specifically rocks that have iron, to be created.
Wow.
After a certain period, those rocks were not formed ever again, meaning that there was oxygen now, both in the atmosphere and in the oceans, oxidizing this iron and not allowing it to form. So that's how we know the history is written in the rocks.
Wow, so as a geologist, a rock to you is like looking through an encyclopedia, looking through a book. It's written in the granules within that rock. Amazing.
It's our own time machine.
Yeah, that's right. So these organisms, how are they linked to us as human beings? I mean, we're going back 3.5 billion years. These children who are watching at home today, like, what role do they play in terms of, I mean, they're alive, we're alive, how are we linked?
So it is incredibly exciting to think that this organism, this eukaryotes that at some point appeared in our planet due to this oxygenation event, they are linked to us. They are our ancestors somehow. And the reason why is that life forms started to reproduce, so they started to mix their genetic material, and this genetic material started to change through time progressively, bit by bit, making life forms differentiate them from themselves.
I see.
So from these common ancestors, we are all here. Us, dogs, cats, whales, we all come from the very beginning of this life.
Wow, so these are really our great-great-great-great-grandfathers.
Exactly right.
How exciting.
Try to picture a world before the dinosaurs, before the mammals, or before anything walked on the land at all. This was the Paleozoic Era, and Earth's first explosion of life. For billions of years, life had been small, hidden beneath the waves, but then, one day, something incredible happened. Suddenly, the oceans filled with strange, alien creatures, giant armored fish, spiky trilobites, and swirling tentacled beasts. Tiny plants began creeping onto the land, followed by the first insects, their delicate wings buzzing in the humid air. And then came the moment that changed everything. The first creatures crawled out of the water. Their fins became legs, their gills became lungs, and for the first time, the land was alive with movement. Forests of towering ferns spread across the continents, filling the air with oxygen. But Earth is never still. The Paleozoic era ended with a disaster. A mass extinction wiped out most of the life that had emerged from the oceans, clearing the way for something new. The age of reptiles was coming. But it all began here, in a time when the oceans ruled, the forests flourished, and life took its first steps forward toward the world we know today.
For 540 million years ago, it wasn't only the oceans that were changing. Yes, they were teeming with life. And yes, some of that life was starting to find its way onto the land. But because the continents had now collided to cause Pangaea, the first supercontinent, we now had landforms. And as you can see behind me, we've got a range of mountains. And these were going to change the way that the entire world worked in terms of weather and in terms of ecosystems, just like the ecosystem we can see here today. So let's go and find out exactly what happened. I can see Marcos right there waiting for us. Let's go ahead. So 540 million years ago, clearly the Earth started to change. The oceans start to become busier, teeming with life. The land around us changed its form. Mountains are created. Life started to migrate from the ocean to the land, and the whole Earth came to life, setting up the stage for all life to thrive. And to help us understand more about it, Marcos is here waiting once again. Marcos, hello sir!
Hey Gavin!
How are you?
Excellent, and you?
Sorry about the delay. It took a long time to get here.
Yes. Very, very impressive place indeed.
Indeed. So 540 million years ago, we leave the Proterozoic era and we move in to the Paleozoic era. What's different? What has changed?
Yeah, a lot has changed in that period of time. So it's the beginning of the Paleozoic era. It's what it's called the Cambrian explosion. There was an explosion of complex life. This is why the Paleozoic era, it's also the beginning of what's called the Phanerozoic. And Phanerozoic, it means visible life. This time we're not talking about tiny little organisms, we're talking about different creatures. And in the beginning they lived in the ocean.
Yes.
So things like trilobites, things like ammonites, things like brachiopods. These were creatures that were living in the oceans, and it's the beginning of big animals as we know them today.
Right, and this life is in the ocean, and it starts to consider moving onto the land. I mean, today, in 2024, we have life all over the land. Why did it move to the land, and what was some of the first creatures that decided to make that shift?
Exactly. So before and now we are surrounded by all of this vegetation, all of this greenery. Before then, nothing lived on land. Nothing. No animals, no trees, no plants, anything.
Just rocks.
Just rocks and volcanoes and snow and ice, and that was it. So again, this life form started in the oceans, and they became also the first vertebrates like fish. Fish began to populate the oceans. At some point, there was a lot of different changes in the oceans that made those inhospitable as well. So life decided to conquer land. The very first ones to do so were early plants. So very early plants, non-vascular plants like mosses and different seed plants were the first ones to populate it. After the plants, then came the invertebrates, different early insects and arthropods. They decided to come as well. And then a revolution, the first vertebrates became to populate land as well. So now land was populated for the very first time in the Paleozoic.
Right, and these continents that they're populating started to move. We had this shift, and something remarkable happened.
Yeah, so at one point we got what it's called a supercontinent, and this is when most of all the land masses of Earth unite in one.
Wow.
And that was called for the last one, Pangaea. There
Okay.
were many supercontinents before, but the last one was called Pangaea. So imagine that suddenly you have a huge continent, of course, that disrupts a lot of this ocean circulation and patterns in the atmosphere. And what it was before forests and swamps became a desert. So life had to adapt again to new conditions. So this is where, for example, the first reptiles came to play, because they were adapted really well to this arid and desert conditions.
Right, so we have life in the ocean, evolving, deciding to populate the land. We have plants, insects, anthropods. Supercontinent appears. What happens next?
So what happened next is really the end of the Paleozoic era, and this is a massive extinction. So unfortunately, life that flourished and diversified into all of these different species, including the earliest mammals we started in the end of the Paleozoic, they came to a massive extinction that got rid of about 90% of the species in the oceans and 70% of the species on land due to a very catastrophic event.
Okay, and what was that catastrophic event?
So that catastrophic event, we think now has a lot to do with a huge amount of volcanism that happened around what we know now as Siberia.
Okay.
A lot of CO2 spewed out in the atmosphere, changing the conditions and acidifying the oceans, warming land as well, and not allowing that life to flourish anymore.
Wow, and I guess the creatures that lived on Pangaea at that time didn't have the ability to see it coming and then try to stop it happening.
Exactly.
It started with a world of recovery. The greatest extinction in history had just wiped out nearly all of the life at the end of the Paleozoic. But Earth, as we will learn, is resilient. And from the devastation, new rulers emerged, the dinosaurs. And for the next 180 million years, they dominated the land, growing bigger, faster, and more fearsome. Some, like the towering Brachiosaurus, stretched their necks to the treetops. Others, like the velociraptors, hunted in deadly packs. And then there was the Tyrannosaurus Rex, nature's most famous predator, its roar shaking the ancient forests. But the Mesozoic wasn't just about dinosaurs. The first birds took to the skies in this time, and their feathers a glimpse into the future. Mammals were there too, small, quiet, waiting for their time. Even plants evolved, with flowers blooming for the first time in Earth's history. Then, in a moment of cosmic fury, it all ended. A massive asteroid, traveling faster than a bullet, slammed into Earth. The skies darkened, the world burned, and the dinosaurs, once invincible, were no more. But life didn't end. It evolved, and from the ruins of the Mesozoic era, the age of the mammals began. The age that would one day bring human beings.
So 250 million years ago, the Earth started to change significantly. This was the age of the dinosaurs. And after the greatest extinction that ever occurred on the planet, life was set to change forever. And we have found Marcos once again. How are you?
Hey Gavin, excellent.
Talking about extinctions and nature bouncing back, look at the life on these bird cliffs here.
Amazing abundance of life.
Where are we?
We are in northern Iceland in an island called Grimsey Island that it lies just in the middle of where the Arctic Circle intersects our planet.
And it's amazing how it's so cold, but life is so abundant. Let's go back 250 million years. The mass extinction is over, Pangaea is formed. What's happening?
So at that time, of course, this big amount of volcanic eruptions made a lot of life on Earth extinct. Life on Earth had a bit of a reset and a start over. So a lot of life forms that didn't exist back then started populating our planet. This is what we call adaptive radiations. They have the Earth for themselves. And the ones that were successful in this era were the reptiles in the beginning. And then these reptiles diversified and made also the dinosaurs.
So why were the dinosaurs so successful? We know there's so many different types. The T-Rex, the Diplodocus, these are amazing creatures. What made them so dominant?
So again, they had a few adaptations that were excellent for them to conquer the different environments. So they have this locomotion adaptations, their feeding adaptations. There were dinosaurs that were herbivores, some dinosaurs that were carnivores, and they ruled our planet and the different environments. And talking about Pangea, Pangea was in the beginning all together and they adapted to that, but then it started separating and they were adapted to different places in different ways.
So Pangea is this supercontinent, a mass of granite and other types of rocks all congealed to make one huge landmass. But the volcanoes that are erupting and changing the atmosphere and the landmass around us, how did they impact this? What caused Pangea to split?
Yeah, so what happens with big supercontinents is that the heat that is inside our planet cannot escape. So at some point, just when you're baking a cake, it starts cracking up in the middle. Pangea was the same. The heat was trying to escape, and at some point it drifted away and it pulled apart that big continent. And those gases that poured into the atmosphere with all this volcanism, they warmed our planet up. So during the Mesozoic, during the era of dinosaurs, our planet was very warm.
Wow, okay, a lot warmer than it is today.
A lot warmer than it is today.
And that's because the gases had changed in the atmosphere, causing this greenhouse effect and other forms that cause the Earth to heat up.
Mostly that was the reason.
Right, now, dinosaurs are famous for being on land. We've all seen the videos and the images of them eating from trees and the T-Rex chasing down its prey in the jungle. Did they live in other places? Were there dinosaurs that lived in the sea? And were there any dinosaurs that lived in the sky?
Yeah, there are actually reptiles and dinosaurs that were colonizing different environments. So again, we're starting from one environment, one supercontinent that broke apart, and that meant many oceans, many different settings where dinosaurs can colonize. So they had all the place for themselves and they adapted to different conditions. So reptiles flew over Earth. Huge reptiles were on the oceans, very scary indeed if you look at them. And dinosaurs on every single place that you can imagine.
Yeah, one of those is the megalodon.
For
what
example.
an amazing creature.
Yeah. As we said, about 150 to 200 million years of evolution.
Wow. So Pangea started to break up. This supercontinent filled with dinosaurs, Diplodocus, all these reptiles, T-Rex, started to separate. Volcanoes erupted, fault lines occurred, and it started to float apart like jigsaw pieces in a jigsaw puzzle. Did the dinosaurs just float off like a boat or a floating iceberg?
No, that's what's interesting. Being that Pangea was separating, different environments were developing. So at some point, this evolution branched out and different life forms appear in different places. And this is one of the ways geologists can tell that this was connected. For example, with plant life. When we have continents are together, this plant can bridge between different places. Once these continents drift apart, in a way, this can no longer exist. So different evolutions happen in different places.
So when we look in the stone, for example, on the east coast of South America, and we look in the stone on the west coast of Africa, we can see similarities. What clues lie in the stone that tell us that these two were once connected?
So a lot of these are actually fossils, old life forms that existed in a similar area and region, but then again they were drifted apart later on by plate tectonics. This also can happen in rock evidence. Rocks are very similar. Once together, they were separated.
Wow, so really, once again, written in the rock is the history of our planet. This is the study of geology, really. This is why it's so interesting.
The dinosaurs were gone. The Earth was quiet, but not for long. With the great reptiles wiped out, the world belonged to something new. Small furry creatures, named as mammals, emerged from the shadows. No longer in hiding, they grew larger, faster and smarter. Some took to the trees, others to the open plains. And over millions of years, they evolved into creatures we'd recognize today. Wolves, whales, elephants, and eventually human beings. The landscapes transformed too. Towering forests covered the continents, vast grasslands spread across the plains. And the Earth's climate shifted again and again, shaping the survival of every living thing. Then, somewhere in Africa, a new kind of creature appeared, one that walked on two legs, used tools, and thought in ways no other animal had ever done before. That's right, humans. From the ashes of the dinosaurs, through ice ages and migrations, the story of life had led to this moment. The Cenozoic Era wasn't just the age of mammals, it was the era that made us.
252 million years ago, we still had Pangaea, one solid continent upon which all life lived on the land. But things were about to change. The volcanic eruptions that were occurring all over this continent did something astronomical. They broke the continent apart, creating coastlines all over the world, like the coastlines we see here, filled with life, but also creating the continents and the countries that we know today. Landforms all over the world, like the Himalayas, the Andes, and even the Rockies, were formed during this tectonic shift, and this would set the stage for animal life around the world to reign and thrive. So let's go and find a gentleman who can tell us exactly how it all happened. The dinosaurs had reigned on Earth for almost 200 million years, dominating the landscape and all other organisms with their giant size, huge teeth, and their ability to hunt and reach food in all locations. But an asteroid was about to impact Earth, and that was going to change everything. In fact, it was going to drive the dinosaurs to extinction. But not all was lost. And we're with Marcos, who's going to tell us more about the Cenozoic Era. Marcos, how are you?
Hey Gavin, excellent.
What an amazing spot.
It's amazing. We're here in the northernmost part of Iceland, full and surrounded by seabirds.
That's right, and we've wandered into the Arctic Circle. It's cold here, but on this dreaded day, 66 million years ago, it wasn't so cold. An impact struck the Earth, there was an eruption, there was fire, there was fury. What happened?
So a big asteroid collided Earth. It was actually bigger than Mount Everest.
Wow.
That's how big it was. And it shocked our planet with as much energy as hundreds of atomic bombs.
Oh my goodness.
So of course that generated a big change. A lot of the atmosphere was obscured. The photosynthetic organisms could not do it anymore. And that meant that all life forms that were bigger than 1 meter perished on land.
There was no food for them to eat, the sun was blocked, the Earth became dark. So what happened to the dinosaurs?
So the dinosaurs, unfortunately, even though they reigned our planet 200 million years, they went extinct, most of them. Some of them, as we will see, they evolved into something completely different.
Right.
But some creatures survived.
Right, and those creatures were mammals.
Some of these mammals that were just hiding in little caves, they were hiding in different burrows, they were able to just go outside and start radiating and adapting. Now that these big dinosaurs were not around anymore, they were just able to colonize different environments.
Right, so these became the apex predators. They had the whole world to themselves. They poked their head out of their burrows like the dinosaurs have gone. I have the whole world to myself.
Exactly.
Now, it wasn't just the mammals that thrived, was it? We have a puffin colony here, in fact, one of the largest puffin colonies in the world. What happened to birds?
Exactly. So birds, as we know them today, and they are incredibly abundant in our planet, they also came as an evolution of those dinosaurs in the Cenozoic. So the Cenozoic were a lot of these mammal life forms that we'll talk about the seabirds, and then in terms of plant life, these flowering plants were now the ones that reign our planet.
Right, so the world has really changed at this point. You have this dominant force, they're extinct, new animals come to the surface and they have this mass flowering. Now, did anything happen to the atmosphere? What was happening? Because in the Mesozoic era, the world was hot. A little bit too hot, maybe. What's happening now?
So now progressively we come from this hot era of our planet, and in the beginning of the Cenozoic, it was still very warm. It was still very hot. Even places like Greenland, that we know today as being frozen, was still green, was still full of trees. But suddenly and progressively, the Earth started to cool down.
Okay.
So the ice ages and the glacier ages as we know them, they are a pretty recent period of time, but progressively our planet cooled down.
And Pangaea had separated. It was splitting apart, it was moving quite rapidly, and new land masses were appearing, new landforms. What were some of these most significant ones that we know still today?
Yeah, so in the Cenozoic, starting 65 million years ago, Earth started to look a little bit more like what we know it today. So America was split apart from Eurasia and Africa. Some of these continents that we know today were starting to shape and be placed where we were, but still a few changes needed to happen. For example, the Himalayan mountains, that was an occurrence from the Cenozoic, where India collided with Eurasia, forming this massive mountain chain that we know today is the highest mountains of our planet.
Wow.
Another big difference is Antarctica, that now it's isolated around the South Pole. That got isolated also in the Cenozoic, detaching itself from South America and from Australia.
Wow,
so
amazing.
those are all changes that happened during the Cenozoic.
What an amazing era. We have the dinosaurs reigning, they become extinct, and then we have a new reign of mammals and birds, just like the birds we can see here today.
Human evolution, the rise of the thinker. In the heart of Africa, beneath a golden sun, something extraordinary began to unfold. From upright apes came beings who walked tall, shaped tools with purpose, and began to ask questions. They watched the stars, lit fires, painted on cave walls, and told stories around them. These weren't just survivors, they were thinkers, creators, and dreamers. Over time, they traveled across mountains, deserts, and frozen plains, adapting, evolving, and forming the early whispers of civilization. Villages turned into cities, language turned into culture. Homo sapiens had arrived. And from their journey came art, science, conflict, and compassion, and the capacity to imagine a world better than the one they had inherited.
See, the world was getting colder. Ice was forming on the poles and was spreading across the earth. But in the center of Africa, in a small pocket near Ethiopia, things were not changing at all. It was actually staying warm, and an evolutionary miracle was happening. The meteor had struck and clouds were in the sky and dinosaurs had perished. But the mammals that could burrow in the ground and forage for nuts and berries were hibernating and waiting. And when the clouds cleared, they appeared to find they had the whole planet to themselves, and they were able to evolve very, very quickly indeed. And that is where the story of humans comes in. Let's go and find out more about it. Now, when the skies had cleared and the mammals crawled from their burrows, ready to evolve, they had 60 million years to change the way that they were going to live on planet Earth. And eventually, they would evolve into Homo sapiens and then human beings. They would even evolve to be able to use rocks, like this piece of basalt, as tools. Tools very much like the tools you use in your household today. Let's head to the top of this waterfall and find exactly how that story played out. And after a long walk up this glacial valley, I finally found Marcos, who's going to help us with this huge question around human evolution. Now, Marcos, before we begin, there's a waterfall here. It's fed by one of the largest glaciers in Iceland. I understand around this time, 6 million years ago, the world was getting very cold.
It was starting to become slowly but progressively colder until finally we reached the last glacial age, and that was only 2.5 million years ago.
So let's go back to the beginning. So the asteroid strikes. We have this huge ash cloud in the sky. Photosynthesis ceases to exist almost, and therefore there's a breakdown in the food chain. Dinosaurs are wiped out. Does anything else survive?
Yes, indeed. This was one of the challenges that life faced throughout our past history. This wasn't the only massive extinction, but it was one that was very important. After the dinosaurs went extinct, some creatures, the smaller creatures on land, were able to survive. Some of them are our ancestors.
Right.
They were burrowing, they were sheltered from this massive explosion that happened back then, and they were able to make it.
Right, so the cloud that was in the sky was there for around 4 to 12 months, scientists predict. So they emerge from their burrows, these mammals. They come out and they have the whole world to themselves. What happens then?
Exactly right. So again, when life finds these empty niches, they colonize, they spread, and they evolve very rapidly. And this is what happened to mammals. They radiated across our planet, both on land and the oceans. After the dinosaurs went extinct, the Earth was still very warm, and our ancestors, old monkeys, they were living on forests because Earth as a whole was still very warm.
Wow, it was covered in forests. Apes and monkeys were foraging and living in the trees. Now, in Central Africa, something really interesting was happening because the world started to cool down. What happened in Central Africa?
Yeah, so moving forward, and this is getting closer to our current times, this forest started to become grasslands,
right,
and savannas,
okay,
and places where now our ancestors, these ancestors that were now and before in trees, they had to go on land.
Oh,
they no longer relied on them climbing and grabbing fruits, but they were now starting to hunt on land and be hunted also from predators.
So that would change the way that they had to act and the whole status of their body.
Exactly.
What happened to the way that they evolved? Did they start to stand up?
Yeah, exactly. So their locomotion now was bipedal. They had, like we have now, straight legs and forward-facing feet. So their locomotion became like that, and that also freed our hands to do things with them.
And that's not the only thing that happened. So these earliest ancestors, these apes, these monkeys, started to have something magical happen. Started to have language. What happened?
Exactly. So progressively, and this is very, very interesting indeed, they started to make shifts and evolve in different ways that were not only biological, like we are accustomed to up until now. Up until now, all of the life forms were evolving biologically speaking. Their genes were changing, and they were getting these new limbs, these new capacities, these new ways of living. Now it was things that they started to do, like building tools, like manipulating fire, like communicating, like you're saying, and that was the thing that started to change back then.
Well, Marcos, there's so many creatures on the Earth that are intelligent. They work in pods, they work in teams, they can even communicate. What made these early humans so special?
So really what it comes up to is our cognitive abilities.
Cognitive ability meaning brain power.
Meaning brain power. Our brain size is a lot larger than other brain sizes compared to our size.
Okay.
And this was the thing with our ancestors, and it continued throughout our human evolution until we finally reached something anatomically similar to us about 250,000 years ago. And this cognitive ability was what led us to be able to communicate, to gather knowledge, to accumulate knowledge, and to evolve through time. Now, in a way that we harness the power of the environment, we adapt the environment towards our needs. But this is jumping ahead, but this is very, very important and very distinctive to humans.
Wow, that's so amazing. The Holocene, the age of civilization. Roughly 12,000 years ago, the ice began to melt. The earth warmed, rivers flowed freely, and life settled into a gentle rhythm. This was the beginning of the Holocene, a brief, calm breath in Earth's long story. Humans no longer chased their food across the plains. They planted seeds, raised animals, and built homes from stone and mud. Villages grew into kingdoms, then nations. The Holocene gave rise to writing, farming, trade, religion, and cities of unimaginable size. It was the era of invention, of pyramids and poetry, of laws and learning. For the first time, humans were not just part of nature, they were shaping it.
Early humans emerged out of Central Africa, and as they dispersed around the whole planet, they started to evolve. Over the next 4 million years, they would evolve in so many ways. Not only would we learn how to use tools, we'd also learn how to use language, but even more importantly, we would learn how to use the land. We'd shift from being hunter-gatherers who were chasing our food to being agriculturalists who knew how to use the land to grow our own food. And although this sounds like a positive move, it also had negative effects on the way the environment changed. Instead of fitting in with the environment, we started to change it to suit our needs. And this shift would have detrimental effects on the whole planet. Let's go and find out more about how it all played out. Now, as the early humans moved all around the planet over the next 6 million years, they would inhabit lots of different locations. But one of the most popular locations for humans was by waterways. Waterways like the one that we are standing in right now. And why is that? Well, in the water is an abundance of nutrients, which means life, which means food. But even more important than that, with water brings fertile land, a little bit like the land you can see here. And fertile land is perfect for growing crops and starting agriculture. And that is what changed the entire planet. Let's go and meet our resident geologist Marcos and find out exactly what happened. Let's go. Over the next 4 to 6 million years, humans would clearly evolve to live on the land and to utilize the land. But as they became more intelligent in terms of their language and in terms of their cognitive ability, their sheer brain power, they learned how to use all of the resources around them to benefit them as a civilization. Things like this stone here, as you can see, it may just look like a stone, but with cognitive power, we can actually use resources provided by nature to build settlements and houses just like this. And that is where the civilizations on Earth took hold. And as they dispersed all over the planet, we saw traditions and cultures that would follow. And we're here with Marcos, who's going to tell us more about it. How are you, sir?
Hello, Gavin.
What a beautiful spot.
Incredible spot again.
Now, as these humans started to evolve, they started to move out of Africa. What was it about the time on Earth that made it perfect for this to actually happen?
Yeah, so we are coming, geologically speaking, out of a glacial period. That's what we call a moment in time where our planet is colder, it's glaciated, and conditions are a little bit harsher. So we move out of that into an interglacial period where we have stable and relatively warmer conditions. So a lot of the places that were before occupied by ice are now free to roam. Perhaps some grasslands start to develop and more habitable land appears for us humans.
Now, as the humans moved around the planet, they started to accumulate and live in certain places. It seemed that water was a really favorable thing. Why was water so important?
Yeah, so humans start settling in different places again with this new and stable conditions. We are now about 10,000 years ago, and specific places were really fertile, gardens of Eden. So when you have enough water and when you have enough resources, you can just lay low for a while and be in a similar place. You don't need to chase the animals anymore. You don't need to move around to hunt and gather, but you can settle down.
Right, and so this came with this sheer cognitive ability, or brain power as it were. We started to not only learn how to speak and learn how to come together and work as a team, we learned how to use tools. Was it just the resources like rocks and sticks and stones that we used, or did we use living things as well?
Yeah, so by then we learned how to harness fire, how to use tools, and how to understand nature. So these places, this very fertile places, allowed us to settle down and work the land for our own benefit. So we were not hunting and gathering anymore, we were harnessing the land for our own benefit. So that was really the beginning of agriculture as we know it, and this was a revolution. This started to happen in different places at different moments in time, but we believe it started around the River Nile in Egypt around 11,000 years ago.
Right. So around 11,000 years ago, we have some of the earliest civilizations on the planet start to emerge. We have the early Egyptians, we have the Sumerians, and we have Mesopotamia, all gathering around waterways. Now, we started to harness the environment around us. We started to utilize the materials, the rocks, we started to utilize weather, the ground. It had positive effects for humans because we could now grow our own food and not move. But did it have negative effects too?
Yeah, so what was very important about us being able to harness the land for our favor is that now we had a surplus of resources, of food. And that allowed us to develop into what we know now of societies, of states. Some people were now dedicated to doing different things, like politicians, like artists, like doctors. It allowed not all the people to do only hunter and gathering, but diversify. And that, of course, allowed more technology and more knowledge to evolve. And through time, we got really good at adapting the nature towards our benefit. And this is where some of those shortcomings come. When we stopped adapting to nature and we started adapting nature to us, that's where that shift happened.
Right, and this is the early emergence of jobs, it sounds. That in society, because you're no longer all hunting and gathering because that's essential for your survival, some people are doing certain jobs, some people are helping society to thrive. And I guess this is really important this week, because next week we're heading into the human evolution now and into the future. So in the early stages of civilizational development in these Mesopotamian cultures and in ancient Egypt, these cities didn't look like the cities we have today with factories and roads and cars. What did they look like? What were they actually looking like on a daily basis?
Yeah, so of course, if we go back in time, by then, most of the activity was focused in this agriculture. So a lot of the labor was focused on the ground of harnessing these resources, both from animals and from land. So a lot of this happened in those societies that were a little bit more rudimentary than we now know them. But what the important thing is that a lot of people were concentrated and living together. And this wasn't the thing back then, where people were moving in very small groups around the area. Now people could live together, could think together, could communicate together, and that started to evolve our understanding and our knowledge, really, as a culture and as collective learners.
The Anthropocene, the era that belongs to us. We are now living in a time unlike any other in Earth's long story. Not an era shaped by asteroids or ice, but by the hands and choices of a single species, us. In just a few centuries, humans have transformed the planet. We've cleared forests, warmed the atmosphere, changed the oceans, and built cities so large they can be seen from space. We have left our mark on every corner of the planet. This is the Anthropocene, the age of humans. But this era is not just about what we've done, it's about what we choose to do next. Because now you are part of this story. You are the generation who will decide what happens next, not just to nature, but to humanity itself. Will you protect the forests, the oceans, the creatures who cannot speak for themselves? Will you find new ways to live, to build, to grow that don't cost the earth? Will you use your voice, your ideas, your actions to make things better? The Anthropocene is not just a name, it's a challenge. And it belongs to you. The future is not written in stone, it's written in your hands.
We're here in Iceland, on a volcanic island standing on the crater of a 20 million year old volcano. But for humans, their story would take place over the next 11,000 years. Once they left Africa, they would start to spread to all corners of the world, using their new cognitive ability, their new brain power, their new cultures, language, and intelligence to utilize tools, the resources, and the land to build cities and towns in which they could live and thrive. Now, with this new ability, they would start to occupy every single corner of the planet. And while you may think that islands such as these that have been around for 20 million years in the middle of the Atlantic Ocean were almost impossible for humans to live, we would see that cities like this one just here would pop up out of nowhere. Humans will become so intelligent and so versatile that they will be able to use the rocks, the trees, the land, the water, and even the fossil fuels that hide beneath the crust of the earth to build cities and civilizations just like this, building roads, factories, houses, churches, and transportation systems that would help them along the way, but they would have a detrimental effect on how the world played out today and what would happen in the future. Let's go down to the harbour to meet Marcos and find out more about how it all played out. Let's go. Now, as we head down to the harbour to meet Marcos, it's important to note that humans and nature are always going to be in competition. And the important thing to note is that humans, unfortunately, will always lose that battle. In 1974, a volcano here erupted, burying the entire city. You can see the remnants of that now. And this problem is going to continue as humans start to occupy more diverse landscapes around the planet, and it will impact the way that we live in the future. Let's head down to see Marcos and understand more about how this situation plays out. And after a long walk from the top of the volcano all the way to the heart of the city down here by the harbour side, it's time to meet our geologist to find out about how humans have impacted the world and what the future might hold for humanity if we continue on the same path. Let's head to the ship and go and meet him right now. We finally made it onto the ship in the final part of this course. And to finish this off, we're going to meet Marcos one last time, our resident geologist, who's going to help us summarize everything we've learned and talk a little bit about the future. Marcos, how are you?
Gavin, excellent.
Such an amazing time with you over the last 10 weeks. Have you had fun?
A lot of fun, really. It has been an amazing time.
We've learned so much from you. Now let's round it up. We're now leaving Iceland. As you can see, we're about to head out of this amazing fjord. We've learned so much from this country, a country that's one of the happiest in the world, a country that has 100% of its energy sustainable. What a great example to the rest of the planet. Now, we're now into a point where humans are starting to populate every corner of the planet. What did they do? How did they shape the landscape and the climate? What did we do as humans? There's now 7.5 billion of us.
So we've been talking all this past few days about how humans evolved and they became more technological and they collectively learned how to harness the energy of our planet. First with agriculture and animals, and then now with the Industrial Revolution we learned about fossil fuels and other ways of energy. So we pretty much populated every single corner of our planet.
And what's our responsibility? So now we are on the planet. There's 7.5 billion of us. We're conscious. The creatures that came before us that went extinct, the dinosaurs, the trees, the plants, the trilobites, they left the planet, they never came back. They were not conscious and they didn't have the brain power to realize that they could change things. What's our responsibility now that we know?
Yeah, exactly right. So every species tries to adapt and gather the resources from the environment until that environment is stressed. And this has happened many times in the past. When a species get so well adapted it can stress the environment. And we are doing the same thing nowadays with all of our technological advancement. And as you said, we now know that we are doing it. We are seeing the changes around us. We are conscious. We are seeing this happening. And that is the difference. What you said before. It's not like it didn't happen before that species stress the environment. It's just that we are aware that we are doing it.
And we've really only been doing this intensely for the last 200 years, since the Industrial Revolution, since machines and factories and fossil fuels, and we've caused some major damage. It's a tipping point now. We call it a tipping point. We're at a point where we can choose one road or another road. What does it mean to be at a tipping point?
Exactly. I think we as a society are at a tipping point in many ways. As you have said, this has been accelerating. Our constant evolution, our constant advancement has been accelerating through time. So we are now at a stage where we are about to condition what's happening in the future in terms of where we are heading. Not only us as a society are at a tipping point, but our planet is at a tipping point. A lot of the different glaciers that are around us are at a tipping point near melting. A lot of the species and biodiversity that is going down, it's at a tipping point of it being able to survive or not being able to survive. And a lot of the things regarding climate change, regarding the warming of the oceans are also at a tipping point. Once those thresholds are met and surpassed, there is no going back. So as you said, we are at a very important moment in our history.
Now, a lot of children heard this word climate change. The Earth is heating, the glaciers are melting, the oceans are becoming more acidic. This is detrimental, this is negative, this is not a good direction. What happens if we don't do something?
So yeah, correct. We are understanding now that this trend that we initiated has to stop. We cannot go as we have been going for the last 100 or 200 years. We need to make a change happen.
Now, the last question I want to ask you is this. We often think of ourselves as separate from nature. We're humans, and that is nature. These are the trees, they are the animals, I am a human. Are we part of nature? And when we know that, what does it change in our mind?
Definitely. We are a part of nature the same way a fish is a part of nature, the same way a giraffe is a part of nature. We have evolved from these eukaryotes that we discussed a few days ago all into this species that is incredibly complex, perhaps the most complex that has ever existed. And we have the responsibility now being so the case. And we are surrounded by the nature that it's also holding and making all of this possible. So of course we need to appreciate that, we need to care about that, and we need to make what it's needed to be done in order for a sustainable future.
Now, over the last 10 weeks, we've been here with Marcos, and we're very grateful for that. We've been here with the Icelandic people in the Icelandic culture, learning from everybody and everything around us. But what's more important than that is the future is actually in your hands. Children who are watching this, students who are taking this course, remember, the future goes on, and now you understand you're part of a story that goes back 13 billion years, and you have the power to make the next set of years all in your hands. Marcos, it has been the most phenomenal 10 weeks with you. You've taught us so much. Extremely grateful and thankful, and I just want to say thank you.
Thank you very much, Gavin. It was great to be a part of this.
Goodbye.